Hi, my name is Dr. Bill Cordua, and I'm a geologist with the University of Wisconsin River Falls. It's my purpose in these short videos to show you the details of the various interesting geology that surround us all every day here in Pierce and St. Croix counties. Today I'm out on the bypass near River Falls, just a little bit north of the hospital, and one of our large road cuts. I'm sure everybody in town has driven through these from time to time and maybe even wondered what they are. Well, they're exposures of a very famous formation called the St. Peter Sandstone. This sandstone body was named for exposures along the Minnesota River Valley and type locality at Fort Snelling. The Minnesota River Valley used to be called the St. Peter River, hence the name was attached to the formation. I made a little cartoon sketch of the rock layers exposed in the River Falls area, ranging from the youngest material, which include glacial drift and river sediments, down through some of the much older bedrock formation that we see exposed in the bypass, along the Kinney Canyon, and from which we get our water supply. The glacial drift and recent material were all deposited within the last million years or so. The rocks below that are much older, representing ages ranging from about 430 million years to 500 million years old. If you do pull off to look at these road cuts, you need to be very careful that you pull far enough off on the shoulder to not be endangered. There's a lot of traffic along here that moves pretty fast, so you don't want an accident to occur. As you look at the road cuts, you see they're also made in 3 tiers. At the top of each tier, there's darker material, which is asphalt, that was spread on top to help slow down the rates of erosion. The road cut is not made as one continuous steep cliff because the rock is not really strong enough to stand up to that high a slope. So it's been terraced back to those 3 different levels that you see. Notice the holes in the outcrop. Those are swallows' nests built when birds quarry into the soft materials of the cliff face. Some of these go back nearly a foot. You can see how much erosion has taken place since these road cuts were put in 1993. The sandstone here is coated with a darker layer. That's a product of weathering and other limey material that's washed down over the outcrop as time has gone by. There's also been enough undercutting here that a lot of the asphalt has fallen off the sides of the cliffs, which is why when you approach this you really ought to have a hard hat on, because these things can fall down at any moment and are really much harder than the sandstone. Once you get past this weathered coating, the sandstone is very soft and can be easily disaggregated in one's fingers. So you have to be very careful by walking around here that material does not fall onto you when you get close to the road cut. In fact, I'm not very comfortable standing even this close, even with my hard hat on. So I think what we'll do is we'll move to some place where the St. Peter Sandstone is a little more easily seen, a little more safely seen, and that's going to take us over to Mound Park over in River Falls. Well, we're up on the road leading up to Mound Park in River Falls, and if you walk about halfway up the trail, you'll be able to see on the left side of the trail some more of the St. Peter Formation, exposed a little bit safer and easier to get to than out at the road cuts. If birds have no trouble carving holes into the St. Peter, you notice that people also take advantage of it as well to carve some nice graffiti into the rocks here. Well, once they get past the weathering rind, the rocks are really very soft. As I demonstrated before, it breaks up very easily into small sand-sized grains. Now if you take a microscope and look at this fine-grained material, you'll be able to see very easily and say it really looks like beach sand. It just looks nothing like beach sand. And you would be right, because that's the interpretation that this rock was deposited as part of a large sandy beach a long time ago. This is on the Florida Panhandle, not far from Tallahassee. This is an example of what River Falls, Wisconsin might have looked like 465 million years ago, when we had a shallow sea here depositing sand on a beach and just offshore in the shallow sea. The St. Peter Sandstone is a rather special sand. For comparison, let's first look at some local river sand, here highly magnified. Notice how it's made of many different minerals, some of which are angular and vary in size. Now for comparison, let's look at a photograph of some St. Peter sand. The St. Peter sand grains are nearly all made of the same thing, hard, durable mineral quartz. Notice also these grains are more rounded and all about the same size. This kind of sand forms when the rocks are thoroughly weathered, probably more than once, so that all the less stable minerals are worn away. Then the winnowing action of gentle waves and wind have removed most of the small particles, leaving behind a very homogeneous sand. In order to understand how fluids like water or natural gas or petroleum move through a formation like the St. Peter, we can consider this beaker that I've filled with these little styrofoam balls. These little styrofoam balls are the equivalents of sand grains. And notice as I pack them in here, I can pack them in here pretty tight, but there's always some spaces between these. These are called pores. And this pore space is where the water exists and where the natural gas and petroleum will also be able to flow. There's no big cavities or tunnel ways or anything like that in the formation, but there's plenty of space between these little spheres in their porosity to accommodate fluids. For example, I have some colored water here, and if I pour the colored water into the beaker, I think you'll see that the pores fill up from the bottom, and there's plenty of room there for quite a lot of fluid in here. And the fluid can move this way or that way by seeping between one or another of these little pores. So when you think about fluids within the earth, within rocks, they're generally not flowing through great big openings. They're generally seeping from one pore to another in rocks that have a lot of this porosity and permeability, sort of the equivalent of what you see here in the beaker. You'll often see people pulled over by the side of the road digging this material out for use in sandboxes. And that's certainly a nice use for it, but there are many other uses that the St. Peter can be put to. Be made into glass sand and other sorts of industrial applications. But one of the more recent uses for it is as frac sand. Frac sand is sand that is mixed up with a number of different chemicals and pumped into rocks that are very, very tight, but have oil and gas in them. The oil and gas can't seep out of those tight rocks, so hydrofracking is a process by which those rocks are cracked, and sand and other chemicals are injected into to hold the cracks open so the oil and gas can escape and be collected. In order to be a frac sand, you need a sand that's very homogeneous, and the St. Peter is. You need a sand that's very durable, and of course the St. Peter is made mostly of quartz sand. The sand grains need to have about the same size and the right degree of rounding, and the St. Peter qualifies in all those regards. And there are places in the world where the St. Peter Sandstone is used as a frac sand. As good as the St. Peter is as frac sand, there's an even better formation in our area that has been widely tapped for frac sand, particularly in the last few years. That formation is called the Jordan Formation. It's another sandstone. It's important to us in River Falls because we get a lot of drinking water out of it. However, the Jordan Formation isn't exposed around here. In order to see it, we have to go further south where erosion is cut a little bit deeper. And we'll be looking at the Jordan Formation in one of my other programs. Thank you very much.